of this in the presentation I have. But basically, we developed a new approach, new model. We call it horizontal model for analyzing complex trace, which contains longitudinal data and single records. This is really important for breeding companies because they mainly have got single records average daily gain leading percentages, or they have got feed conversion ratio of the whole period. Now we see that there is differences in the curve of feed efficiency. Then if you want to include that into your breeding program, you need to have this horizontal model to account for the permanent and residual variances in your model. So for feed efficiency, you will have feed intake as a longitudinal trait. We have average daily gain and lead mean percentage. And this model that we developed is supposed to partition the residual variance or environmental variances into its permanent and residual variance separately. That allows you to estimate the genetic correlation and the residual correlation between the traits. So the objective was to better understand and model feed efficiency during the growth, and it gives us the chance for selecting for the curve of the growth rather than having an average trait. Then used to develop this model. For some reason it doesn't come up over there, it's down below here. And for feed intake, we have got like 7 weeks. We made them based on the weeks. And then we have got the average daily gain and other production traits like lean meat percentage. I need to mention we used the downbred data set because that was really larger. We had 67,000 Europe's and we had 121,000 land-raised animals here. So we use this horizontal approach. We featured the fixed part of the model is just like a segmented analysis. So every section has got its own intercept. And then we fitted the curve for the genetic part and the permanent environmental section, and then the residual comes separately for each trait. It allows basically to model every section of the model separately. And then we estimated the feed efficiency with RFI and in a genetic way. The presentation I did was based on the phenotypic level. Now we went to the genetic information of the animal, and we separated the genetic effects of production from feed intake. And that allows us, I wrote the model up here, so that allows us to have no correlation, no genetic association between the efficiency and the production. So easily you can select for this trait without affecting any of your production in your breeding program. And we saw a really good heritability ranging from 0.1 to 0.2 for both of the breeds in downbred data. And here I've got the correlation between lean meat percentage and feed efficiency. And as you see, the correlation comes down, and that tells me that animal gets fat and the efficiency gets lower at the end. And that's the correlation between the feed intake and average daily gain. And the correlation increases to 0.9, 0.8, I guess here, and it drops for Durox, and it remains up for landrace. Basically, landrace indicates that it's much fatter in the last stages, and you can see it through the correlation with the limit percentage that the landrace is much fatter than Durox animals. And the correlation between RFI during growing finishing period was the same as what I showed for Hermitage data, and the correlation between early RFI or feed efficiency is really low, around 0, with the late feed efficiency. There are different traits, so that's why we are suggesting to select longitudinally and select for the curve. And basically that was the conclusion of the study. We showed that this model can be applied into the breeding programs. We concluded that feed efficiency needs to be analyzed in different stages of growth, and there is potential for selection for the curve of the growth. Thank you very much.